In this example, we are given time dependence of the position of the particle, which is as follows. X as a function of time is given as 70 t squared minus 6t cubed. Well, the first thing to note here is that these coefficients here, 70 and 60, are not just numbers, but they are numbers with units. So, what are the units of 70? To figure that out, note that x by itself has units of meters, and this has units of seconds squared. So, number 70 should have units of meters per second squared. Here, prefactor 6 should have units of meter per second cube, using the same logic. So the question is, what is the maximum positive x position that is reached by the particle? So this is part A. Now, to find that, let's first find the velocity of the particle. Now we know that velocity, the instantaneous velocity, is the first time derivative of the position. So dx dt. So we can take a derivative of this. So the derivative of this gives us 140 t, and the derivative of this is minus 18 t squared. Now what kind of dependence is this? Clearly this is a parabola. If you draw it with respect to time. So let's go ahead and draw it and see how does velocity depend on time graphically. Now, when we have a graph, and clearly here a parabola has either a maximum or a minimum, so we need to figure out this position at where it has this extremum. So to do that, we need to take another derivative of v, and that would be acceleration. This would be dv dt, which is 140 minus 36t. And to find that point of extrema, we need to set this equal to 0 and find that t0. So this t0 becomes equal to 140 over 36. If you calculate this gives you 3.8 seconds. So at time t, 3.8 seconds, velocity either has a maximum or a minimum. So what is it, a maximum or a minimum? Well, because this prefactor next to t squared is negative, it means that the two branches of the parabola are facing down. So if we are to draw the graph, just a sketch of it would look something like this. Where this is 3.8. if this is measured in seconds. Now, how do I know that the parabola, one of the branches of the parabola, passes through the origin? Well, if you look at this, at time t equals 0, velocity is equal to 0. So it has to go through the origin. What about this second point? To find that second point, we just have to set this equal to 0. And calculate for the time t. As you can see from this equation, the first root of this equation, t1, is equal to 0, and this is what we've already talked about. And then the second one is 140 over 18, which gives us 7.7 seconds. So now we are ready to draw some conclusions regarding the x. As you can see, for the first 7.7 seconds, the velocity of the particle is positive. In other words, it's moving in the positive x direction. After 7.7 seconds, it still moves, but now the velocity has changed its direction to opposite, and now the particle is moving backwards. Which means that the particle will reach its maximum positive x position at time t equals 7.7 seconds. And that answers to part A. So the time at which it reaches its maximum positive x position is 7.7 seconds. In part A of the question, we realize that the particle is moving in the positive x direction for the first 7.7 seconds. After that, it reverses the direction. In part B of the question, we need to find the total length of the particle covered during the first 15 seconds. And note that we need to find the length, not the displacement. So how do we do that? Well, let's first find the displacement, and then we will find the length. So the displacement of the particle covered in the first 7.7 seconds can be found from this equation. So x of 7.7, which is 70 times 7.7 squared, minus 6 times 7.7 cubed. So if you do the math here, this gives you 1,411 meters. So let's call this x1. And now let's find the displacement in the first 15 seconds. So x2, 15. 70 times 15 squared minus 6 times 15 cubed. And if you calculate this, this gives you minus 4,500 meters. So now let's show this on the x-axis. This is the x-axis, this is the origin. In the first 7.7 seconds, the particle travels to position 1,411 meters. So it gets here. In 15 seconds, it gets to minus 4,500. So it's somewhere here. This is not to scale, this is just a sketch. And so what was the actual motion? The actual motion was like this. So it started from the origin, it got here, and remember, then it reversed direction, and then it got here. So the question is, what is the total length of that path? Well, you can see that to find the total length, all we need to do is to add two pieces like this and one piece like this. So this means that 2 times 1,411 plus 4,500, and this gives you 7,322 meters. This is the total length, while this is the total displacement. And by the way, this answers part C of the question. And this answers part B of the question.